Hello YouTube. Welcome back to Josh's Garage. Today we play with distributors.
So are you recording all of the nefarious activities?
Alright, so one thing about distributors, we have a motor switch here, right? So this is our on switch for the machine. Left-hand drive and right-hand drive. Depending on the timing chain arrangement, the camshafts may rotate opposite or with the direction of the crankshaft. In the case of the Miura, the crankshaft rotates opposite. It's one of the few streetcar engines that rotates counterclockwise instead of clockwise. And the distributors also go counterclockwise. So when you're looking at the weights here, right, these pins are different, right? Because obviously to get this to go this way, right, this is going to have to spin in this direction.
Yep.
So to go the other way, these little guys would have to be flipped, right? Like this. And then it would work in the opposite direction.
Right.
And it also has some measuring tools on here, right? So we were talking about a condenser earlier. So this machine has the ability for us to do some testing on the condenser, as well as dwell, right? So we know our points are set up, how fast we're spinning it, so we can watch what our advance curve is. And then we also have what's called phasing, where we talk about each set, right, fires 3 cylinders. And so this being a 6-cylinder distributor, it fires every 60 degrees.
Yeah.
Okay? But we have 2 sets of points that do that. So in addition to all the stuff we talked about earlier, remember we were talking about the position also changes how soon and how late that they activate. So if you don't have these centered properly, one side will fire maybe every 60 degrees perfectly, and this side may not be perfect. And most of the book stuff will tell you, you want it to at least be within 1 degree from one side to the other. Because again, as we talked about, these distributor ignition systems are not the most precise.
Right.
So you're gonna have an error no matter how hard you try. And this is a simulation. When it goes on the engine, there's other things going on. So, it doesn't necessarily perfectly do exactly what it did on the machine on the engine. So, it's all fairly relative. The machine's real noisy. We gotta let it warm up for a bit because the power unit for testing the condenser, it has to warm up. So there's a couple of things there. Before we do that, bust out some of this stuff. So when you're restoring a distributor, right, you gotta have parts. So here's a handy little parts kit.
Springs and...
Yep. Springs, curve bushes, various nuts, washers, some old spare parts. You got to have a parts kit if you're really going to do these things, because you never know what kind of condition they're going to be in, and shipping gets real expensive.
Yeah.
Black oxide, period correct looking screws, clips, castle nuts, rivets for the data tags. We'll talk about data tags here real quick too. Bearings. Because as you notice, they spin, so there's bearings.
Yep.
You want to replace the bearings because, if those aren't running reliably, then the shaft will move around and you'll get erratic spark behavior and stuff. Some gaskets, little felts. These guys get soaked in oil and then get stuffed in here. So there's always a light oil on the cam lobes, because this is a phenolic material here. Right, so you want to keep a little bit of lube there because it's spinning at several thousands of RPM for years at a time. So you want to keep that little guy lubricated. Some more various screws, plastic insulators. This is where our stud and all of our electrical pass through, because again, as we talk about, we only want the points themselves to be the ground point. You don't want it grounding through the body.
The housing to ground out.
Yeah, we can replace other hard parts, These are pretty expensive. I don't really keep a whole box of those, but the little nuts and screws are the things where the shipping costs more than the parts. Some of the shop manuals have stuff. Some of them don't have so much. This is like we had the Weber Carburetor Bible.
Yep.
This is the Marelli Distributor Bible. It doesn't go all the way back to some of this real early stuff, but you see it's got some later single distributor Lamborghini stuff, and it's got some Ferrari stuff. So like we were talking about the Daytona.
Yep.
distributor we had, S138B. Let's assume that we're going to tune the Daytona distributor. Some mechanical drawings, right? So like when we made the adapter that distributor's mounted on, we've got some drawings there. This is our advance curve. You'll notice that this is not, normal engine RPM, right? It goes from 500 to 4,000, as we talked about. The cam and distributor spin at half speed of the crank.
Yep.
So this would be a 1,000 to 8,000
Whoa.
crank RPM
Yeah.
scale. So you can see here, this is our degrees. This is shown, this is a pretty linear ramp, right? From in the first 500 RPM, it goes from 0 degrees to what is that, 7 degrees?
Yeah.
And then it very steadily goes up to 13 degrees plus or minus 1.
And you gotta double it, right?
Yeah. So on the test bench, we'd be looking for this literal, right? When we
Yeah,
spin it on the
yeah.
machine, we want to see 7 degrees by 1,000 RPM, and then we want to see the other, what's that, 5
Right.
degrees,
Yeah.
6 degrees up here by
You said
3,500 RPM.
Yeah, 13.
But if it was spinning on the engine, first we want to see 7 degrees, and then we need to see another several degrees for 13 total from our 0 point.
Right.
But if you had the timing gun on the engine, right, that would be 14 degrees and 26 degrees at 2,000 and like 7,000 RPM.
Okay.
So the other specs we were talking about, right? Here's our points,
Yeah.
okay? Open and closed. See this? This is our cam. We've got a delta here, and it gives us a breakdown on what we want our dwell reading to be. This is a theoretical mechanical gap setting because you got to have a base point. So you use a feeler gauge,
Yep.
do your initial points gap setting with that, and then you spin the machine up and you check it in degrees. Remember that? Grams. This is our
The weight?
Yep. This is our spring strain gauge measurement we do to
okay.
test it. So this is the Morelli Bible. It's mostly got Lancia, Fiat, Alpha stuff in here, of course, because they were much more plentiful. But this is a guide that we would use similar to the Weber book to make sure that our distributor had base settings. Parts diagram of the distributor. You got your condenser, you got your points, you got your mounting plate, various hardwares, activating cam, rotor, distributor. You'll see some of these are highlighted and some of these are not. The highlighted or dark colored pieces are things you can order. The non-colored pieces are considered, not purchasable as service parts. You'd have to buy a
The
complete
whole thing?
distributor. Yep. You got your item number list here, Morelli part number, or in this case, a Ferrari part number. Back in the day, you could have, ordered all this stuff. You notice here, item 20, which is our points. Okay.
Okay.
But it's listed twice, quantity 1 each, 2 different part numbers, letters C and L.
Yeah.
As you notice, the way these guys come in, right? So we got the hole here where the electrical comes out.
Yep.
So if you compare that hole to where each point is set, different positions.
Yeah.
So one point has a short wire, one point has a long wire.
Okay.
Those part numbers differentiate C and L for short and long wires.
Oh.
So this would be a guide that you'd use when setting up a distributor. So let's say it's one I've never seen before. It's not one I'm familiar with. Like this. Let's say there you go, Lancia Fulvia Coupe, 1200 cc. Let's say I've never rebuilt one of these before. A guy just shows up, with this car and says, "Hey man, I need my stuff serviced." Without knowing anything else about the car, I could pull his distributor out and do a diagnostic on it and make sure the internals are set up properly and running properly, using my test bench in this book. In this book here. The gurus will tell you, of course, you learn, over the years, different settings. This is a good known base setting, but if you got more camshaft, more compression, different fuel, who knows what, old tired motor, worn out ignition components, maybe this book setting is not ideal for that particular engine's condition. So you might change your dwell angle and change your advance curve. Like one big thing that I've been doing is with pump gas cars, because of the slower flame front speed of the ethanol enriched fuel we have, is we'll bring the advance in much sooner than we used to help restore original engine power.
Power,
Yeah, we're not making new power, we're just gaining the power we lost. Combustion and ignition, as we probably talked about before, It's all about pressure in the cylinder, right? Flame front speed, completing that ignition of the fuel and air, right? So you have to accomplish that within a specific time frame, right? And that time frame depends on the octane of the fuel. In this case, there being ethanol, the compression of the engine, all of these sorts of things, they all affect how quickly the mixture gets combusted and fired. So you may have to change your timing advance and your dwell rates and stuff to, get that maximum ignition back again. Because this was, designed on 100 octane 1960s pump gas, leaded pump gas, totally different than what we're running today. I know if I put this in, the car will at least run, and it's not gonna, hurt itself or anything bad's gonna happen, but, we may find that it doesn't make the best power or original power even, and want to, customize that, that distributor. And this bench allows us to do that real easily, because they're hard to work on the distributors when they're on the engines. It's not impossible, but it's difficult. Yeah, it's not warmed up yet.
Okay.
So on the condenser meter,
Yeah.
right now, I've got the, see that?
Oh, yeah.
See how it just woke up?
Yep.
So this is a resistance adjustment, see this? So I've got the leads together.
Yeah.
I'm gonna calibrate the test unit. Now I know I've got a good test.
Okay.
So now,
Oh, okay. Yeah. Whoop.
there you go. So we're in the black, that's good. If we're down in the blue, that would be bad as far as the resistance check goes. So now we know that we've got good connections and a good condenser there. So now we could do a capacity test. That's good. See, it's all the way down in the black.
Yep.
Okay. Go that way. Back in the black. So we know our condenser's in good shape. If it were in the blue during any of those tests, that means it's working inadequately. The condenser has a specification on it, microfarads, right? What its capability is. So you know what that is, and then you do the test, And I've already run this, so I already know this has not been calibrated on the machine. I just did a bench assembly on it, so like we notice like the points here aren't perfectly aligned and stuff like that. I've already run this and I know this isn't perfect, and I left it that way so we can illustrate the value of using this tool to calibrate and diagnose, right? If it worked perfectly, it wouldn't be so obvious what we're trying to do. You got dwell, right? So same thing, you want to calibrate your dwell meter. Set line, because I've already done it, right? Put that guy there, put that guy there, right? 8, we're on a 6-cylinder, right?
Yep. Whoa.
See the light flashing around?
Yeah.
So now we're right on 0, and you can see we're watching all 12 cylinders, right? Now we're gonna do what we call checking the phase, which is what you were talking about earlier, where each point fires 3 cylinders.
Yeah.
We want to make sure that all 6 are firing at the same point, right? So we stuff a little paper in there. Now that point won't make contact.
Yep. Oh yeah. So it's only 3 of them.
Yep. So we're on 0 here, right? That's our reference point. 120 there.
Yep.
Okay. This one's hard to see, but it's also at 120.
Yep.
Right? So now we've got our known start point there, right? All right, now we're checking our other set of points. So that would be at 60. You can see we're off about 2 or 3 degrees there, right?
Yep.
Off about 2 degrees there.
Ooh, it's also occasionally shooting there.
Well, the paper might not be.
Oh, there it goes. Yeah, now it's gone.
Yep. And then you come over here and it's still 2 degrees. So that tells us, right, that the lobe is pretty geometric, but this set of points over here is not positioned equally to this set of points.
Yeah.
So I'm gonna have to loosen up the base plate and move this counterclockwise to change that position 2 degrees retarded, right? Because right now it's 2 degrees advanced. The other thing that's important we talked about is our dwell. You see here we got 24 degrees of dwell. on that. Now we'll check the dwell on the other side. And this will tell us whether or not the point gap is balanced left to right.
22.
22. So pretty close.
Yeah.
A couple degrees different. So now we know we can refine our dwell. We also know that our dwell is not ideal for a 6-cylinder motor at 24 degrees. And we know that our phasing on this set of points is off. So we need to move this guy up, and then we need to change our gap on our points to change our dwell. Now we would map our advance. Okay? See how we have increments here?
Yeah.
So we got two different speed scales, 1,000 RPM and a 6,000 RPM, right? So we can go from 0 to 1,000, and then we'll go from 1,000 to 6.
Yep.
This wants us to start here at like 250. Say, all right, so we got 0 degrees, right?
Yep.
Then it wants us to go to 500, right? So we double it. Still got 0 degrees, right?
Yep.
So no advance yet. Now we go to 750, right?
Oh, definitely getting the.
Little scatter.
Yeah.
Yep. Yep. So that would, re-verify that we got to work on our points adjustment because we got some scatter down here. That's not ideal. You just want to see 6 points. But we know we don't have to worry about that one. We know this is a good 0. So at 750, there's still no real advance, right?
Yep.
Okay. So now we're going to go to 1,000. All right. So now we've got 2 degrees, right?
Yep.
So now I'd put 2 degrees at 1,000. So now we got to go up. See, now we're still at 1,000 RPM, but we're on a new scale.
Yep.
So now we're going to go to 1250. Maybe 1 degree. Looks like we went from 2 to 3 degrees there.
Yep.
Okay. And then 1,500. There you go. Now we're up to the 5 degree mark, right? So we gained a little bit there. 5 degrees means 10 degrees at the crankshaft, right?
Yep.
So at 1,500 RPM, if we're using a time light on the motor, that means we'd be at 3,000 RPM, and we're at 5 degrees, so we have 10 degrees of advance.
Yeah.
So if we started at, we're going to use Mira numbers. So let's say we started at 20 degrees initial, right? That means now at 3,000 RPM, we've just gained 10 degrees, so now we're at 30 degrees of advance at 3,000 RPM.
Yeah.
And then you just keep going up the scale, right? So now you go to 1750. We gained another 2 degrees. Gained a little more, right? See, so these motors run to 7,500 RPM.
Yeah. Jesus.
That's what your distributor's doing at 7,000 RPM.
That's intense.
Yep. And that's kind of how you tune a distributor right there. That's how you map the timing curve, the phasing of the points, check the dwell, all the things that the distributor needs to do. The final check would be is I would take a dummy distributor cap, an old junk one that I've drilled holes in so I can see the contact points in it. And with this on, I would rotate until it lit up on a cylinder, and then actually visually take a look at the rotor.
See, it's at the right cylinder.
Yep, and make sure that, because now I know the distributor is mechanically phased within itself, but now we want to make sure that, with that being said, that the rotor's in the right place, because since we have slotted adjustments, right, if the points are phased together, they could still be, one way or the other with a few degrees. So if you're not careful, even though your phasing's good and everything looks good, your rotor could be over on this cylinder and the point's open getting ready to fire long before it gets to the next cylinder. So it's trying to fire the wrong cylinder at the wrong point of time.
Right.
And it's going to do that for every cylinder because your phasing is balanced between all 6, but it's off several degrees.
Right.
Or even worse, if you've got it off in, you know, in the advanced direction, and then the advanced curve starts to come in now as as you're really running the engine up to revs and, you know, demanding a lot more from it, and it's advancing timing. Now it's trying to light the cylinder after the cylinder you're trying to light, and that's obviously pretty bad too. So there's, you know, another dimension to making sure that it's all calibrated. And this is why you can't just do this on the bench with your eyes and throw it on an engine and, you know, guarantee a top result.
Yeah.
It may run, it may seem like it runs fine, but, you know, it's probably not going to. It's going to be difficult to tune, and it's not going to drive real smoothly, and it's not going to make best torque and power. Just like with the timing advance, you know, if we lock this thing, and I've seen it before, at 20 degrees, Mirai worked on the advance, for some reason, it was all jammed, probably because it wasn't serviced right, you know, for a long time. So when they adjusted the distributor at the timing light and got it to the initial setting of 20 degrees, which is correct for that engine, it was 20 degrees through all RPM ranges. So once we found that and we fixed the dwell setting and we fixed the advanced curve in and put it in and had that full sweep to it, we actually gained 50 horsepower.
Oh yeah.
Out of a 300 horsepower engine, we gained 50
That's
on a
huge.
dyno just by fixing the dwell and putting, you know, timing, you know, 10, 15 degrees worth of timing advance in it with the distributor. So it's super important that these are calibrated properly, you know, not just kind of winged.
Man, that is super, super cool.
Yeah. So now you got both sides of the coin. Now you know how to build a Weber carburetor and how to tune a Marelli distributor. As you can see, it's real simple. It only took a few minutes to do this tutorial. You too can tune a race-winning engine.
But not really.
But not really.
No.
No. No.
You too can pay Josh to make you have a race tuning.
Well, you can see how tedious this can get, right?
Oh,
Like,
yeah.
it's simple principles, but you got 8 or 10 different things you got to pay attention to. And like all things, you know, they all affect one another. So if you lose track of anything,
Well, I'm just thinking about the complexity of, okay, so you got to fix this distributor, get it all perfect and whatever. And then you have another distributor to do the exact same thing too. So like,
yeah.
this is easily a full day, if not more, of work.
Yep. Yeah. It depends on how trashed the distributor is. Yep. But yeah, once you calibrate this one, then you calibrate the second one, double check and make sure that the advanced curves are, you know, they match as close as you possibly can. As you can see, the precision of this equipment is, you know,
Yeah, pretty good.
It's pretty
okay.
good, but it's not, you know, laser perfect.
Yeah.
You might be off, you know, a degree or so, but yeah, it could take you all day to, you know, get within that degree. And then you got to hope that the valve adjustment was right, the cams were timed right, the compression's good, you know, all the rest of it. Always check your spark plugs first.
Yeah.
Yeah.
Jeez.
Yeah, but it's fun stuff. You know, it's cool when you take a motor that just doesn't quite seem to run. It runs, but doesn't quite run right. And then, you know, you do something like this and then, you know, it opens right up. One thing we'll do real quick just for fun is I'm going to blow open the gap on one of these points, and then we'll slide this plate, and then we'll see what we get out of that set of points.
Oh, okay.
Just so we can see live here, right? We
Yeah.
saw what we had for dwell. We saw what we had for phasing. So let's mess with these two things right quick, and then we'll see firsthand. Did a couple quick adjustments, right? We talked about we got these two screws here, which hold the base plate that holds the points to the distributor body. Loosen those up. That changes our phasing. I slid it forward. I couldn't tell you how much. We'll find out in a minute. But now I only lightly tightened one.
Yeah.
So that way, if I don't like it, I can just back it off and I can adjust it live. And
Okay.
we'll watch it settle and then we'll snug it down. And then there's these two little screws inside here. These are the screws here that hold our base plate down that
Yep.
determine our phasing. This is a locking screw, and then this is a cam screw that adjusts our position of our points and our dwell.
Okay.
So that I loosened and then retightened, but same thing while it's spinning on the machine, I could live adjust this while I'm watching the machine. See that? See
Oh,
how
yeah.
it moves the plate?
Yep.
So if you're here, you know, there's no top plate to support it, so we
Yeah.
got a lot of deflection going on. There you go. See that? How it opens up the...
Yep. Yep. I see it moves
So-
a tiny bit.
Yep, so that will affect our dwell, and the first adjustment affects our phasing. And so now we'll spin the distributor up and see. So here you can see 42 degrees of dwell I now have,
Yep.
right?
Hey, look at this one's now right at 60.
Well, I guess I don't have to play with that adjustment, huh?
No, I think you fixed it.
All right.
Maybe
So
tie that one down.
I'd say I could move it if you guys want to watch it move just for the fun of it.
Oh, it did. It did as you tightened it.
Yep. It just moved.
Yep. Oh, now it's at 60 again.
All right, cool. So we're gonna lock that guy down right there. So you can see how sensitive this is, right?
Yeah.
All that was just tightening and loosening the screw.
And it went 2 degrees.
We went, yeah.
Wow.
That should be pretty good. Might not be perfect, but 32 is pretty good. Okay. So now we can say that side is probably pretty dialed, right?
Yep.
You can see when you change the dwell, it changes your phasing as well.
Yeah.
Because like we talked about, you're changing how close the foot is to the low.
Yeah. So it's gonna change where timing it hits.
Yep, so you gotta keep chasing it. As you just saw, we changed the phasing, then we changed the dwell, and then we had to change the phasing again. And then we come over this side, change the dwell, now we gotta change the phasing. Then we gotta recheck the dwell. Just like with the carburetors, when we're doing the idle mixture,
Yeah.
it's a constant chase. When you're doing your dwell and your phasing, there's gonna be overlap. So
Yeah.
you do a little dwell, you do a little phasing, do a little dwell, do a little phasing, on and on until you get both sides totally balanced and tuned together.
So once you've got the distributor totally set up and locked in, then you put it on the engine, and then you still got to rotate the distributor, right, to get it to the right position?
Yeah, you gotta top dead center your cylinder 1, make sure you're on your compression stroke, and then you notice there's a notch in the distributor body.
Okay, right there.
Yep, and there's a pin here that aligns the distributor cap.
Okay.
So this will always be your cylinder number 1.
Oh, so you'd want the
rotor pointing at this when you top dead center set cylinder 1 on the
Gotcha.
compression stroke on the engine, and then you put it all together. And then once you fire it up, you got to rotate the body using your timing light to make sure that your initial firing point is where it's supposed to be.
Jeez.
Which on a lot of these early engines, they really roughly mark this stuff, so you can't super count on the machine marks, as in don't at all trust them. You really have to use a dial indicator and stuff and TDC the motor and make your own marks and stuff.
Good Lord.
That's the general crash course on tuning one of these dual point 3-lobe Morelli distributors. And the S85 was used on all the 250s, 275s, all the Lamborghini Miras up until the later SVs got a single distributor. So this is a really common distributor in the 60s. Ferrari and Lamborghini is pretty standard stuff when you're working on those cars.
Well, YouTube, my brain hurts now because that was a lot. Although I have to say, I learned a lot. Like, I know the theories behind it, but to actually see it physically in motion is pretty amazing. Thank you so much to Josh. Again, exotic-power.com if you need any of his services. Obviously, he doesn't know anything about these cars, so don't send your cars here ever.
I did my first oil change last week. But don't worry, you'll get a bill in the mail anyway.
Also, if you want to support us and the channel, go visit normalguysupercar.com. Use the code NGS10. It takes off 10% almost everything in the store. Don't forget, we're doing the 355 project car. We've got my 458 to put back together. We still got the boat and some other cool stuff. So you guys are amazing. Thank you so much for watching. We're going to be doing a lot of car stuff. You're going to want to stay tuned.
It will be sweet.
Generally. Oh, it'll be sweet.